This system of equations is genuinely a joy to solve. Take a look at these two equations. We have three unknowns, x, y, and z, but only two equations. At first glance, anyone with a bit of math background might say, "Hey, this is impossible. You have more variables than equations, so there's no unique solution." But wait, there is a hidden detail here that changes everything. Our unknowns must be natural numbers. This small constraint is the master key to this puzzle. Ready to solve it? Now, you might be tempted to try the obvious route, squaring both sides and subtracting them to use the difference of squares. But let me give you some friendly advice. That path is a total trap. It will drown you in complex calculations. In mathematics, we always search for beauty and simplicity. So, what's the best strategy here? Let's look at the right side of the equations, 2027 and 2026. The difference is exactly 1. So let's keep it simple and subtract the second equation from the first. By doing this, our expression becomes x plus yz minus xy minus z equals 1. Now, look closely at this. Do you see a pattern? We have 4 terms that we can group in pairs. Let's factor out the variable y from the middle terms, giving us y times z minus x. With a little more factoring, we reach this elegant form, x minus z whole times 1 minus y equals 1. Look how sleek that is. We've turned a messy system into the product of 2 parentheses equaling 1. The question now is, in the world of numbers, when is the product of 2 integers equal to 1? Let's explore the possibilities. Case 1. A number multiplied by its reciprocal, like 2 times a half, or 3 times a third. Case 2. Both parentheses equal positive 1. And case 3. Both parentheses equal negative 1. Let's test case 1. In this case, a would have to be a natural number greater than 1, like 2 or 3, or a negative integer less than negative 1, like -2 or -3. But, wait, if our second parenthesis, 1 minus y, has to be a fraction like 1/2 or 1/3 to satisfy this, then y would no longer be a natural number. This means hitting a brick wall against our main constraint, so case 1 is completely impossible. Now, case 2. What if both equal positive 1? If 1 minus y equals 1, then y must be 0. But is 0 a natural number? Absolutely not. That leaves us with case 3. The product of 2 negatives is positive. If both parentheses equal -1, what happens? Let's calculate. 1 minus y equals -1. From this, our first unknown appears like a hero. Y equals 2. This fits the natural number condition perfectly. Now that the first piece of the puzzle is in place, the rest of the dominoes will fall quickly. By substituting y equals 2 into our first original equation, we get x plus 2, z equals 2027. From the first parenthesis, we also know that x minus z equals -1. Now we are looking at a clean classic system of 2 equations with 2 unknowns beautifully shown here. To finish the job, we just multiply the bottom equation by 2 to line up the z terms. Adding them together completely eliminates z, leaving us with a simple expression. 3x equals 2025. With some quick mental math, x comes out to 675. Finally, plugging that back in gives us our last unknown. Z equals 676. Isn't that amazing? We started with a seemingly impossible system and used the power of factoring and logic to find 3 natural numbers that fit perfectly. Now, it's your turn to show off your genius. Take a look at this challenge. Solve the equation x squared minus y squared equals 31 for natural numbers, and write the value of x in the comments. Here's a small hint. 31 is a prime number, and meaning it's only divisible by itself and 1. I'm excited to see who gets the right answer first.